Hello, 11th graders. Today we're going to be moving on from right triangle trigonometry. So moving on from our SOHCAHTOA type of trigonometry and moving into trigonometry with non-right triangles. When we've been talking about right triangle trigonometry, all of our angles we've been talking about have all been less than 90 degrees. They have all been acute angles, acute because they're just so tiny, right? So it's all been less than 90 degrees because you cannot have a right triangle where one of the other two angles is 90 degrees. We can have one 90-degree angle, which is what makes it a right triangle. But if any of those other two angles end up being more or 90 degrees, then it won't become a triangle. Because if you have two 90 degrees, then you can't connect that third side, right? So we've only been talking about acute angles, and now we're going to move on to non-right triangle trigonometry. And then the very beginning of this lesson talks about angles that are greater than 90 degrees and what they mean in terms of right triangle trigonometry. So we are first going to start talking about larger angles in trigonometry. How we like to think about these off the bat is we put trigonometry onto a coordinate plane. So I'm going to first just draw a coordinate plane. This guy is X and this guy is Y. I want to talk about the theta angle, theta, which let's have it be 135 degrees. So if I were to peel off to make that 135-degree angle, I start right here on my x-axis and I move my way up such that it makes 135 degrees. I chose 135 degrees because I knew it was 90 plus 45. So just keeping that in mind. So this is our angle that we want to talk about. This is theta in a coordinate plane. How we build a right triangle from this is that we cannot build a right triangle that includes 135 degrees. So instead, what we do is we build a triangle that involves the 135 degrees. So that is the right triangle that we draw when we're talking about that. Really, what it creates is I can't go in any further. That's a 45-degree angle. Sorry, it's a little messy. That's a 45-degree angle. And then we would build our right triangle up from that. And then we'll talk about how to get our exact values. I don't know, and this is the hard part about this online learning, is I can't take a quick poll of you guys and know whether or not you've learned about the unit circle yet. We are not going to talk about the unit circle because we're not going to talk about radians, but this is, if you have learned about the unit circle, this might seem a little bit familiar. The unit circle is a circle that's on the coordinate plane, and it has a radius of 1, and it's centered at the origin. And from this unit circle, we talk about all the different angles that you can make, all the way from 0, 30, 45, 60, 90, all the way around to 360. So we talk about all those different angles and what their measurements are, what their exact values are, because sine of 45 degrees is root 2 over 2. And it comes from this coordinate plane relationship with right triangles. So this is bringing in that idea. We talk about with our 45, I'm debating about how far I want to get into the concept here. And I think what we're going to do is just remember what the exact values of our 45, 45, 90 right triangle is. Remember that it's an isosceles right triangle because both of those acute angles are equal to each other. They're both 45 degrees. And if we can remind ourselves, that means that we have 1, 1, and square root of 2 as our side lengths here. Now, since we're on a coordinate plane, technically we're going in the negative of this direction. So technically our x value, since it's going in the negative, this guy is going to become -1. Now, can we have negative measurements? No, we can't. But since we're talking about this on a coordinate plane, we're talking about going into the negative for you this way, into the negative of the x values, but then still going into the positive for the y values. So we could say, well, cosine of 45 degrees of this triangle would be adjacent, which is -1, over hypotenuse, which is square root of 2. So let's do it to the side here. Cosine of this 45 degrees is -1 over square root of 2, which if I multiplied top and bottom by the square root of 2, I would get -√2 over 2, which means that that is actually what the cosine of 135 degrees is. We could talk about the sine value as well. The sine of this 45, let's call it like 45 prime, because it's not really 45, but it's what we're using to make sense of this right triangle, is going to be 1 over the square root of 2. Multiplying top and bottom by the square root of 2, we get √2 over 2. And that's what sine of 135 degrees is. You can plug it into your calculator and then plug in the value √2 over 2 and notice that it comes down to the exact same value. If I were to do sine of 45 degrees, like just a normal 45 degrees, it would be √2 over 2 as well. They both are positive. So I want you to pay attention to here that if we're talking about if we're talking about sine of an angle, the sine values will always be positive. Let's get a blank coordinate plane. Sine will be orange, and then cosine will be blue. If we look back over here and we're talking about the right triangle that we're making, the sine value always includes the opposite side length, and as a result, that will always involve our vertical shift or our vertical movement. So if we have a triangle that's been made in this coordinate plane, sine will be positive here, and sine will be positive here. But if we made an angle such that it peeled up and around and went all the way down to here, which would be an angle that's greater than 180 degrees, then sine would be negative because the opposite side length that we would build from this angle right here, that guy would be negative, and therefore the sine value would be negative. And then, sine would also be negative here. Cosine is the adjacent side length. So if I were to build a triangle anywhere off of this diagram, the adjacent side length, because we're always talking about that angle at the center, the adjacent side length will always tell us whether or not it's going to be positive or negative, and it's going to be positive in this part of the graph when our x values are positive. So cosine is positive here. Cosine is positive here. Whereas cosine will be negative here and negative here. So that's kind of the idea. I know that if you haven't seen anything like this before, all of these ideas are going to be kind of weird and wonky and they probably don't make a whole lot of sense right now. And I want you to allow yourself some space and some freedom for it to not make sense right now. We're going to do another one in this example of building a right triangle given a certain obtuse angle. I'm going to double check that it's not one. We already did 135. So let's do 150. Yeah. So we'll do another example.